Good afternoon, everybody. Good afternoon, St. Xavier's College, and good afternoon, Azerbaijan State Oil and Industry University. Dear participants, chairs, the organization committee of the workshop dedicated to the applied to the 100th anniversary of the Azerbaijan State Oil and Industry University, and the about advanced applied high-performance computing systems. Now, if you are, I hope that everybody is available, and so we can start today's event. Tapalina, if you don't want to say something, I want to produce the invited talk from the Azerbaijan State Oil and Industry University.
Yes, Nigar, you can continue.
Okay, thank you. Now I want to ask the invited professor of the university and also the chief of the HPC center under the university, Ehsan Musevi, to present his talk about the politics of the HPC center, usage of the HPC center, and also the challenges in exascale computing systems.
Thank you, Negar. I try to share my desktop. I try to share it. Okay. Do you see my desktop?
Yes, we can see your presentation.
Thank you very much for appreciated this concept and this presentation. As you know, our HPC centers and our Advanced Research Center about the high-performance computing system work based on the cluster computing, and we are working about the running and executed scientific programs or scientific models. As you know, in high-performance computing systems, we have it four parts: hardware, HPC manager, application, and a library. In our HPC centers, like another HPC centers in Europe, our focus on the HPC managers, and we are focusing the design and develop HPC managers. As you know, HPC managers must be managed systems to running the application by the reduced time, and the HPC manager must manage system to obtain high-performance computing system. As you know, we had two approach for reaching the high-performance computing system. One approach using the spatial hardware, a spatial operating system, a spatial library, and a spatial compiler. It is a very expensive approach, and only in the world United States can use this approach for running the scientific application. In the Europe and in the Asian countries, we are using the cluster approach for obtaining high-performance computing systems. In the cluster computing systems, we are using the off-the-shelf computer and off-the-shelf network, normal network, to reach a high-performance computing system. For these reasons, we need to design and develop a spatial high-performance computing system manager. High-performance computing system manager included remote process manager, load balancing as an axial units, process migration, remote node selection, resource discovery, and inter-process communication units. In the Azerbaijan Oil and State University, we are trying to design and develop LB, PA process migration, and the resource discovery. 2 years, we can design and develop a spatial inter-process communication manager for Azerbaijan HPC national programs. And After it, we can plan it to the writing a special remote procedure manager and remote node selection. Now, challenge about if you know, we have one challenge in the HPC systems. That challenge is the related and mentioned that exascale computing systems. As you know, after the many conference that DOE presented in the world, we decide to design exascale systems. But changing from the petascale to the exascale is not similar to changing from the gigaflops to petaflops, because changing when we want to change the era of the petaflops to the exaflops, our programs is very different from the traditional programs. In the exascale computing systems, we try to run application that discovering cognitive basic rules of the natures. For example, one of the very important application that we are trying on the Europe countries is the climate simulation. We know only some rules about the climate simulation, and we try to using the Ulish Computer Center to reach and understand what is another rules that covered or that influenced on the climate simulation. Another example is very, very important for us, because we only simulate 8 minutes from the 24 hours of the brain working. And it is important for us, we understand what happened in the brain. Another challenge, it is very important because, as you know, NASA started March 200 to 2024 programs is the aerospace weather forecasting. As you know, we have only some limit and some spatial information about the weather forecasting in the Mars, weather forecasting between the Earth and the Mars, and we have a many challenge about it, and we are using our cluster computers in the world to and cognitive what happened in the aerospace weather forecasting. Therefore, Azerbaijan Advanced Research Center of HPC of the ADN ASEO is try to join the many projects about the exascale computing system in the world. Therefore, based on this reason, based on this subject, Azerbaijan HPC centers try to design and develop exascale process migration, exascale load balancing, exascale remote process management, exascale resource discovery, and spatial interprocess communication to support the exascale. I try to narrow on the one of our research in the ADNSU about the process migration. As you know, in the cluster computing systems, we have many clients and we have many servers, and the cluster manager, especially load balancing, maybe the supported this workload between the resource and the requested. LB have 3 main works. 1, collecting data. 2, decision based on collected data. And 3, transfer the process from the one machine to another machine to run the programs in the low response time. What is the process? Process migration only migrate a process from one machine to another machines, and don't collect any information about the machine's state, process state, destination state, and the state of the process in the destination machines. Why this process migrator is activated? Because process in the normally cannot continues the work on the local machines. When when the process migration activate, when the called by the load balancer, and what the transfer between the two machines, transfer code and the data. Code transfer time is very low, and we can ignore it. And another mechanism that introduced in a traditional HPC systems like the MASIX system V Sprite mechanism focused on the data transfer. And we have four basic mechanism for the data transfer, like the total copy, pre-copy, lazy copy, and the flashing process. What is the important point of the process migration? Important point is the process suspension time. In a process suspension time, process cannot continue to answer to another process. Therefore, maybe the process that won't communicate to the migrator process kill by itself, because send the request to the process and process don't answer, therefore kill by itself. In a migration, we have three challenge. One, when we suspend the process in the one machine and the transfer to the another machine, if we can continue the work or we must start the beginning of the work. It is one challenge. Second challenge about the time suspension, and third challenge about the heterogeneous systems. As you know, when process transfer to the another machines, maybe same operating system, same CPU, and same condition is very important for us. We introduced it in the Chenza supercomputing center in Europe around 8 years ago, the live process migration. The live process migration using the virtual machine contain data and process, transferring VM from one machine to the another machine, shut down the VM, and start the VM in other machines. After our works, some persons in the IBM start this works and introduce the total VM migration and partial VM migrations. This subjects that I mentioned to them is about the traditional HPC, but in the exascale we have many challenge. One challenge that is very important for us is the dynamic and interactive events. Pay attention to this point for your university and our university. We cannot continue working on a distributed systems, on HPC systems, without the focusing on the exascale systems, because exascale is the next generation high performance computing system, next generation distributed systems. And if we want to speak about the distributed systems and high performance computing, a contribution about the distributed exascale computing system or this exascale computing systems. Exascale that's introduced by DOE first time is in a hardware terminology pointed to 10 power 18 flops, but in a software terminology it is the pointed and mentioned that's running the cognitive and the discovered applications, such as the brain simulation, high temperature, connectivity, aerospace weather forecasting, and the like this. D&I, until now, we only introduced and presented three types of the D&I. Fork D&I, communication D&I, and interactive D&I. The fork means that one event occurred in a system that create the process that we don't have any response structure for process. Communication communicate to process that we don't have a response structure, and interactive means that one process communicate another process and we don't have a interactive event. For example, in the real world that we are running in the Azerbaijan Oil and State Advanced Research Center of High Performance Computing Systems, and running in the Europe countries, is the weather forecasting models. That in the weather forecasting models sometimes occurred the D&I from fork, D&I from type of the fork, or D&I from type of the communications, and we must support it. For the virtual migration function, we introduced this functionality that show us that the function of the migration is the depends to the process state, process memory, process dependency, VM state, and all of them based on a state of the virtual machine process. As you say, this definition is very different from the traditional traditional process migration definition, because, as you know, in the traditional HPC systems, in a traditional process migration, the base of the function on data, and on the how data transferred, how data remaining, and the like this. But in this function, the main element or axial element based on a state, and we have a challenge of the state of the process, and we redesigned the state of the process for this session. When the end I occurred, the state of the process or state of the virtual machine, source state, destination state, and the VM transferability state may be changed. We have we in the world, we in the Europe Computing Center, we are using the deep machines for deep, not deep learning, only deep. Deep IBM machines to obtaining the exascale computing systems and the deep operating systems that's written by IBM. In the Azerbaijan Advanced Center, we are using the special operating systems for mass computing system that need the exascale concept. They are in this operating systems, we are using the global activity concept and dynamic state concept to manage influence of the dynamic and interactive events on a process state, VM state, and another elements states. We think that live migration can be support exascale systems if we can redefine a state, redefine system state, redefine replacement global activity as a process, and expanded the dimension of the VM to two dimension, and change the communication state with an offin page. As you know, offin page is usual concept for understanding communicated between two processes in distributed system, and the state concept must be extended. If I have another part of my presentation about how to access to our HPC centers. As you know, we have a very useful computing systems in the Azerbaijan oil and gas universities, oil and industry universities. And if you want to using our HPC centers, first you need to register in our centers, and we create for you based on information that universities send to us account, and using the instruction I show you for accessing our centers. I try to open it. One moment, please. Okay. Do you see? As you see, we can create the account for you, and we have three independent racks that this is computers is very different from together, and you can use the GPU programming, CPU programming, and you can use the heterogeneous computing.
Sorry,
We have
sorry, Ihsan Bey, we couldn't see your desktop.
No?
No, we don't see.
Okay. Thank you for your. Now you can see?
Not yet.
No?
No.
No. Why? And now?
Yes.
Okay.
Now we see. Yes.
Okay, we have three different section in our HPC centers. Rack 1 have a 3 node with the abilities to give you 1 petaflops. Rack 2 give you another 1 petaflops, and rack 3 give you another 1.5 petaflops that powered for you. As you know, you can use the terminal spatial access to our HPC center. You can use this IP address, and we give you IP address and the password, and give you a spatial access, and you can run if you need to a spatial cluster manager, we can set up on your machines, and we create for you a spatial environment to run your application. Now we are provided the service for the other space, and other space based on this protocol start they're using our facilities, and we trusting organization, but the pandemic is and if you want, we can create for each student or the group of students a spatial user